Ever wish you could like peek inside the mind of a computer? Especially when it's, trying to figure something out. Not just see the answer, but like the actual process, the thought bubble.
Oh, yeah.
That's what we're diving into today.
So I'm like, yeah, how do they get there?
Exactly.
Yeah.
So how researchers are coaxing large language models, those AI brainiacs, you know what I'm saying, into basically thinking out loud with this really cool thing called chain of thought prompting.
And they're doing it by having these models explain their work step by step, just like, what you'd see in a math textbook laid out.
Oh, interesting.
Yeah.
Okay, so we were talking about feeding these models a question, but instead of just like hoping for the best, crossing our fingers, we're giving them examples where the answer includes the reasoning.
Exactly. So think about like a math problem. Instead of just saying the answer is 11, you'd say Roger started with 5 balls. 2 cans of 3, that's 6. 5 plus 6, that's 11. So the answer is 11.
Okay, so it's less about what's the answer and more about show your work.
Yes.
Like my old algebra teacher used to say.
Exactly. It's subtle, but it seems to tap into something that was already there, kind of latent in these models, some ability to reason, just waiting to be unlocked.
Whoa, that's wild.
By giving these examples of like step-by-step thinking, researchers are basically giving the model a framework, right? Like, here's how to approach problems in a more human-like way.
That's fascinating. And research shows this is actually working. The models are getting better at solving these tough problems just by like thinking out loud, basically.
Oh, way better. Get ready for it. Some really impressive results.
So these AI models are like showing their work now, right? And I got to know, like, how does that actually play out in the real world, with real problems? You said impressive results.
Oh, yeah. So there's this benchmark test. It's called GSM-8K. And it's basically a bunch of, grade school math word problems.
Oh,
and these aren't your like, Sally has 3 apples kind of problem.
Right. Like I was actually looking at GSM-8K earlier, and it's no joke.
No, it's serious stuff. Multi-step, tricky wording.
Yeah.
It's the kind of stuff that, really makes you think.
The brain teasers, the like, oh, wait a minute, let me read that again kind of problem.
Exactly.
Yeah.
Exactly. And this is like what researchers use, to really push the limits of like AI reason. And here's the kicker. When they applied this chain of thought prompting to GSM-8K, it like blew everything else out of the water.
Really? So it wasn't like a tiny improvement. This was a big jump.
Oh, huge jump. They didn't just do a little better. They like shattered the previous records for accuracy on this benchmark.
Wow.
Yeah.
Hold on. So they took a single model, right? Not one that was like specifically trained on a mountain of math problems.
All right.
And it suddenly became a math whiz just because it learned how to explain its thinking. That's wild.
It's really amazing, right? Like how powerful this simple change in prompting can be.
Yeah.
And it wasn't just, about math equations either.
Right.
They had similar success with things that need common sense, like, understanding what's going on in a sports scenario or figuring out dates from a story.
Wait, common sense in AI?
Right.
I thought that was the holy grail, the thing everyone says is missing.
Yeah, I know, right?
How do you even measure something as subjective as common sense, though?
So they had like these specific reasoning tasks. So presenting like a scenario and then asking the model to make a deduction or predict something based on what's given. Just like, how we use context and what we already know to make sense of things.
That's incredible. So we've gone from AI struggling with basic logic to this, like understanding complex math and even showing a kind of common sense.
Yeah.
All because of this chain of thought prompting. This is going to have huge implications.
Oh, yeah. Hugely exciting for researchers, but there's like another layer to this. It seems this ability, this using chains of thought, it's tied to something else, something pretty important, the actual size of the model itself.
What? Okay, now I'm really intrigued. So we're talking like how physically big these systems are. Like the more servers they have, the smarter they get.
Well, it's more about their computational capacity, the number of parameters they have. Think of it like connections within their artificial neural network.
Okay.
And what's so interesting is that when they tried this with smaller models, even with those same reasoning steps, it like didn't work as well.
It's like this ability to think step by step only kicks in when the AI reaches a certain size. That's so strange. But why though?
Yeah, that's the million-dollar question, isn't it?
Right.
Is it something fundamentally different about larger models, or is it just, more is better when it comes to data and scale? They don't know for sure yet.
Wow.
But it opens up a lot of new research questions, that's for sure.
It's like we've discovered this secret passage in AI, and now we're trying to figure out what's on the other side.
Exactly.
Yeah.
Exactly. Still so much to learn.
It's like we found this, I don't know, like a treasure chest or something full of all these amazing tools, but like we don't have the instruction manual yet.
Yeah, we're still figuring out how to like really use them.
Exactly. But before we get, too far into that, I think it's important to remember, like, as cool as this all is,
right,
there's got to be a catch.
Right.
There's always a catch, right?
It can't be this good, can it?
What's the downside?
It's funny you should say that because, they found that even when these models lay out their reasoning and it looks perfect on paper, like a flawless argument, they can still get tripped up.
Really?
Yeah.
So it's like they're doing all the right steps,
Yeah.
but then they trip at the finish line.
Kind of, yeah. Like the researchers found that sometimes, even when the chain of thought is perfect, Like, the logic is all there.
Yeah.
The model will make a simple calculation error,
Oh, no.
like a misplaced decimal or something.
So it's like they can set up the entire equation perfectly,
Yep.
and then they forget to carry the one.
It's kind of funny, right?
It makes them seem almost human, in a weird way.
It's true. It's true. Shows that these are still, complex systems and we're still figuring them out.
To their underdevelopment, for
Yeah,
sure.
definitely, yeah. And it highlights something I think really important about all of this right now. The focus is on getting these models to reason in a way that we understand.
Right.
Not necessarily making sure that everything they're using to reason is actually correct.
Oh, okay. So it's like they're learning the process,
Yeah,
but they don't necessarily know if the information they're using is true or not.
exactly. Yeah. It's like you can follow a recipe perfectly,
Right.
but if one of the ingredients was mislabeled or something,
Yeah.
your dish is going to be a little off.
That's a great analogy.
Yeah.
Because it's like the process can be perfect, but if
Yeah.
you're working with bad information.
Garbage in, garbage out, as they say.
Exactly.
Yeah.
Exactly. So this raises a whole bunch of new questions then, doesn't it?
For sure. It's not just about teaching AI to reason. It's making sure that they have good information to work with.
Reliable sources, all that good stuff.
Exactly.
Yeah.
Yeah. So, it's exciting.
Yeah.
But we also have to be mindful of, making sure they're not just intelligent, but also actually using their powers for good.
Ethical, unbiased. That's it.
Exactly. It's a big challenge for the future, but a really important one.
Well, on that note, I think we've definitely covered a lot of ground today.
Oh, we did.
And as always, it seems like we're left with even more to think about.
More questions than answers, right?
Exactly. But this has been amazing. We've opened up this whole new world of AI reasoning and seen how just a small change can make a big difference.
Absolutely.
It's clear that size matters,
Yeah.
but we still don't know exactly why. And it seems like as we celebrate these amazing discoveries, it's more important than ever to remember that, AI is still a tool.
Yeah.
And it's up to us to make sure we use it wisely.
Couldn't have said it better myself.
Well, thank you so much for joining us on this deep dive.
Oh, thank you for having me. This is great.
It's been a pleasure, as always.
Likewise.
And to our listeners, if you want to learn more about this fascinating topic, you know what to do. Check out the show notes for a link to the research paper and all the other good stuff.
Yeah, definitely check it out. It's worth a read.
It's been a pleasure exploring with you all. Until next time, keep those brains buzzing.